Ну что, господа, будем начинать. Последний наш доклад от докладчика security эксперта очередного. Томас Конечный расскажет про security by design. Поприветствуем.
So hello, during my today's presentation in Secure by Design. Maybe a few words about me. I'm Tomasz Konieczny. I work for Boulder as Senior Quality Assurance Engineer. And I'm also responsible for other tasks, like, for example, DevOps-related or security things. And today I will speak about security. But when most people think about security, I mean QAs or developers, they think about this technical part, like, for example, OWASP or some standards. And they often forget that security isn't just this technical part, and that this non-technical one may be even more important in some cases. So this presentation definitely won't be the technical one, because that's just not all. I mean, everyone in the team is responsible for security in some way. For example, developers or QAs or even designers or business people. If you think it would be some BA stuff, well, definitely not. The whole presentation will be based on examples of IoT devices and Tesla software. Let's start with IoT. Huge group of devices that should make our lives easier. That's the goal, at least. And also, it's a great example if you want to talk about security flows. Mainly, it's the concept of connecting just everything to the internet. So maybe a few examples of these devices. By definition, smart devices like smartphones shouldn't be treated like IoT because they are compute devices. But in this presentation, let's assume it's the same. So smartphones, I think everyone has got a smartphone currently. Sensors, huge group of, for example, industrial ones, or basic devices like thermometer or weather stations that we can use at homes. Home automation, another group of devices from intelligent, at least by name, lighting systems or surveillance systems. Devices like refrigerators that we can connect to the internet. Well, that might be a bit funny, but it's possible. There are devices like that. I mean, home appliances, wearables, devices like smartwatches that become more and more popular nowadays. So what I try to show here is that there are devices that there are everywhere around us. I mean, for example, smartphones. And people often complain that, for example, smartphones are rarely updated, that the manufacturers of these devices don't care about users, update the software, for example, 2-3 times, and that's all. But there are more significant problems in case of IoT devices. What about security? Because when you don't receive update of your, for example, phone, then that's something quite obvious. There are, for example, new features that you expect to have that were released, for example, in the newer version of operating systems. But these smaller devices, it's quite easy to even forget about them. For example, if you connect something like intelligent smart scale, then when the way is correct, then that's all you expect from this device. It's even possible to forget that we connected something to the internet. And there are multiple security problems related to these IoT devices. I think that the best summary of it are two quotes. The first one, the S in IoT stands for security. Security was that important to manufacturers of these devices that there's even a shortcut of security in this IoT one. Well, it definitely wasn't important to them. And maybe some example. Go-ahead web server, that's probably not as well known as, for example, Apache or Nginx, but in case of IoT devices, it's very popular. And about a year ago, year and a half maybe, some serious security bug was found. The bug that allowed to remotely execute code, so remote code execution, then it was possible to escalate the privileges to the root user because they were mainly Linux-based devices. And this bug was definitely critical. According to Shodan search engine, if you don't know it, it's a search engine that allows you to find specific versions of software. According to Shodan, there were like few millions of affected devices back then. I mean, a year and a half ago. Currently, there are still a few millions of affected devices. There isn't any change here. Why? Because security isn't just this technical part. I mean, there will always be not yet found bugs, and that's one of the things that we try to teach new QAs. It's not possible to find everything, and it's very important how we solve these issues after they appear. So in case of this web server, this critical bug isn't really a problem, the most important one at least. The problem here is that manufacturers of these devices haven't implemented one basic functionality called software update. So it's not possible to update these devices in any way. If they are manufactured with specific software version, then they will have this version to the end of their life. So that's one of the examples how functionalities or this non-technical part may affect the security. There's also the second great quote, in my opinion, insecure by design, because these devices were designed in that way. I'm not sure if it was intentional or not, but it's really a problem here, that they were designed in an insecure way. And it's not only limited to the IoT devices, because we can do anything that would be designed in the insecure way. For example, web applications too. So maybe the next example, Tesla cars. About a year ago, it was like May 2018, I talked with CEO about security of IoT devices. And one of our conclusions were that car can also be an IoT device. I mean, at least these more technical cars. The best example here would be probably Tesla. So we realized that, and because CEO is owner of Tesla's Model X, we decided to check it. I've got some time after hours or at work for self-development, so we decided to check what is the security level of these IoT devices. So I've been given keys, or to be more precise, password to Tesla's car, because as you can expect from IoT device, there just has to be a mobile application for it. So I've been given this password, I've installed mobile app, and I started my tests. Just to be clear, it's not about a lack of software updates, because in this area they care more about users. Also, it's based on research from April or May 2018. This presentation won't be fully up to date because I haven't tested these devices from that time. There will be one update from November 2018, but still it's quite new thing. So what can you do with this mobile application? You can display car-related information such as battery state of charge, charging details, how long it will take to charge the car's battery. What is the expected range of this car? So you can check kilometers you would be able to drive with it. You can check configuration, so what is installed in this specific model. You can check also geolocation, so you can display a map and check where your car is. For example, if you lose the car on a parking lot, you would be able to check its location. It may be very useful. But you are also able to execute some actions to control this car in some ways. So you can control air conditioning. For example, if it's hot outside, you can turn on the air conditioning, set the best temperature you want before you go to the car. You can blink the lights, for example, to find your car in the parking lot. You can honk the horn, probably for the same purpose. And it's possible to do even more. You can open charging ports or trunks, and you can also open door and start the engine, or at least enable this driving mode. So with this application, you can not only check where your car is, but you can also open door, sit in it, and drive away. It's really a car key replacement. But it's even more, I think. By application like that, you probably would expect that it should be secure. I think that security should be a priority here. But that's not really it here. But maybe one more term related to security, very common one, but not limited maybe to security, a single point of failure. It's something that we try to avoid during the software development. It's the assumption that something will eventually fail. There will always be not yet found bugs, and we have to have specific actions based on that. For example, how to avoid it, where it's used. First thing, two-factor authentication. For example, if you use your bank account, you have to confirm some actions with second factor, like, for example, SMS code or some token. If you use your email, that's the same case, or GitHub, you can enable 2FA, and you not only have to have your password, but also this second factor, like, for example, this token, SMS code, or something else. Other thing to avoid single point of failure can be detection of non-standard user activity. For example, if you know your users, you know what actions can be quite standard, and you can try to predict which actions would be a security threat, for example. The next one is permissions. Related to permissions, this old rule to always use lowest possible permissions. For example, you shouldn't use admin or root user for everyday work. You should use the lowest possible permissions. That would be sufficient in specific case. The next one, isolation. You don't trust your application, that your application, for example, in test mode would be secure. You isolate, for example, test environments so that no one would be able to access them in any way. Because this one layer won't be enough. And also redundancy, that's more specific case, maybe more related to server setups than to the security. But you shouldn't trust one machine to always work correctly. For example, you place multiple machines behind load balancer to handle the traffic. You don't trust that one machine would be working correctly. That last one isn't maybe related to the security, but I try to show you that everywhere we try to avoid single point of failure. And what about Tesla application or cars? Well, this application depends on just one password. So if you know the password, that's all. You can control the car. You can locate it, you can open doors, and you can drive away. It's just one password. You can download the application and log in. You don't need specific device, specific authorized device. There isn't any method of 2FA implemented here in the application. There will be one more update on in the end of the presentation about these features from October that are quite funny. But back then, it wasn't possible to use 2FA in any way. According to authentication or authorization of new devices, it wasn't possible. It isn't possible still. So you don't need specific device that would be some form of 2FA. You need any device where you can download the application. You just open, for example, Android, Google Play in Android systems, install Tesla app, and log in using this one password you already have. Maybe some example. Steam client, let's assume you have a new computer, you install Steam client, and you want to play some games on Steam. And what you need here is the second factor. So the first time you log in, you would receive some code in your to your email. You enter it, and you would be authorized, or at least your device would be authorized. And what's possible here is that you can remember your device. That's the checkbox there. So the next time you want to use your computer or your Steam client, this device will be your second factor. You would need this password and this specific device. So it's not only secure, but it's also very simple to use. So it's possible to implement 2FA in other ways than entering this SMS code, for example, every time. Your device may become a 2FA, your second factor. There isn't also any functionality related to the device management. So you can't check what devices are used if you are used in other devices. You are not able to find out that. Maybe again the example from the service you surely know, Google. That's possible there to display devices where you are logged in. You can even check the location, check specific devices, revoke access. Well, great functionality, easy to use. In case of Tesla's car, well, it isn't available, and also there aren't even any notifications related to security. I think it's quite standard that when you log in, for example, to your email or GitHub, you would receive a notification that you logged in on your device. And in this case, there are a few notifications related to security, but in this physical way. For example, car alarm. I haven't tested this one because it would be probably a bit harmful to the vehicle. But other notifications that are available related to security are just the software update. So if you log in on a new device, you won't even receive the notification about it. And what's even more, maybe one example, when you log in to a new device on Google account, in this case, I logged in on the smartphone. I received notification to not only one mail that I used, but also to other that were connected. So it's possible to implement it in a very simple way. Logging to new devices like new smartphones isn't that frequent. It's only when we, for example, change the device. So it's definitely not a problem for users to use something like that. But about Tesla, there's even this functionality isn't even implemented for password change. So if you want to change password, you have to know the current one, but then you change. You don't have to confirm it in any way, so you won't receive, for example, a link, email with some link that you have to click. You won't even receive the notification that you changed the password. So if someone changes your password, you won't even know that until you try to use the application. What about detection of non-standard user activity? It's hard to be 100% accurate here because it's not possible in this case. But I used the application in quite non-standard ways. For example, I logged in 7 or 8 devices in the same time. I logged in on the new device when the car was like 1,000 kilometers away from me. This definitely can be considered as non-standard activity. I even made requests for the API, to the API like every 5 seconds for quite a long time. I was checking the location using API because there is some REST API used by this application. And I still got access to this device, to this application. So I think that if some detection of non-standard user activity would be implemented, then I shouldn't have the access then. Why is it so critical? Because still it's some password, but in this case, First thing is that this car's value is quite high. Also, it can be dangerous for the owner's privacy, because using this application or API, you can check location, so you can basically track the car's owner, because probably owner would be quite close to his car. You can also access sensitive data using this password, in this case in the website. You can access, for example, invoices or some credit data. Everything with just one password. But what about a password hack? Is it that easy to lose this password? There were multiple leaks, password leaks, for example, last year. If you use the same password anywhere else, then it's possible to lose it. But even if you care more about security, even if you have unique password, you may lose it quite easily because of the ecosystem. Because the car is very technological one, and owners expect some non-standard functionalities. Because of that, multiple unofficial apps appeared. But it's not possible to authenticate in any secure way to the Tesla account, and because owners expect some functionalities or try to implement something on their own, they use what is available. And if there are no API keys or OAuth, that would be a great case here, then they started to use just their login credentials. So there are applications, just to be clear, I'm not saying that these specific applications are insecure, but there are applications, for example, Tesla Spy, that can generate PDF files with your route, with some statistic, or a better route planner that can plan the route based on the chargers. Very useful from user's perspective. But both of these applications ask users to give them their credentials, their login and their password to the Tesla account, which means that they can access the car. And I've been on a few Facebook groups during my research, and these PDFs, for example, were very common there. Owners uploaded these files, and there was discussions about, for example, their roads, their power usage, etc. So it was very common to see something like that there. So these users were using some third-party apps that asked them to give them their passwords. And it's only based on trust. These owners have to trust creators of these applications that they would only really, for example, generate some PDF or check their location and not use that for example, stealing cars. And because of that case, that it's that common to give away their credentials, there is a serious risk of losing the password. But what about user experience? I mean, if we try to increase security level by adding this additional layers like 2FA, then it may be the application may become unusable for user. We definitely have to think about UX too. We need to at least try to find a balance between security and UX, because both of these things should be important. There are a few things that we can consider, like, for example, what are the compromise risks? Is this some internal application or internal block that it's not that important, and, for example, one password will be enough here? Or isn't something financially related, and we have to care more about security? How probable is the compromise? Again, if it's something internal, isolated to specific, for example, network, internal application, or is it something that would be definitely a target for attackers? Also, what level of security would be sufficient? What are some minimum things that we have to implement, functionalities, for example, when the application won't be usable anymore. For example, if we add this additional security layers, then we may lose users. Maybe it's a good thing to think about optional security features. So user may decide if he wants to use additional security layer, like for example 2FA. That's very common. For example, on Gmail you can decide if you want to use it or not. That may be a great thing. But we have to think about one more thing. If lack of functionality may be a threat for security. Because when we create MVP, minimum viable product, then our goal is to create something as simple as possible that will be okay for users. It's very easy to forget about security in these cases. I think that if we think about security, implementing, for example, 2FA or OAuth or something like that, isn't that hard. It's maybe one more day of work, for example. But in case of compromise, if we don't have something like that, then it may be end of the project. The project would be maybe compromised in this case. So even for the very basic applications, it may be important to implement some additional security-related features. And also, we definitely have to think more about security. I mean, not only developers or QAs, but also the rest of the teams. Even designers or business people have to be aware of the possible problems. And also, definitely, we have to remember that it's not just this technical part. I mean, correct implementation isn't enough because in case of this Tesla's application, implementation was probably great. But in that case, it's not only about this part. It's very important to think how requirements may affect security because again, in case of both this first example of IoT device and Tesla applications, it wasn't about quality of software. It's from the technical perspective, at least. Also, it's very important to balance this security part and this usability thing. There will be questions time in 2-3 minutes, but one more update about related to Tesla software that I promised that would be. So Tesla released an update in November 2018. The update allowed users to use some form of 2FA, but it's quite specific. I mean, you can see this huge tablet-like thing in the center of this car console. This 2FA works like this. If you have car key, you open your car, and then to be able to drive, you have to enter a PIN code. The PIN pad appears in the screen, you enter 4 digits. If it's okay, you can drive. What about Tesla application? Well, you open door using your application, and then this PIN pad appears. That's almost the same case. You enter the PIN, everything is okay. But what in case you forgot your PIN code? Well, below that PIN pad, there is a text, forget PIN code, login using Tesla account credentials. So it means forgot your second factor, this PIN code, well, enter password, twice. And that's, again, about requirements or assumptions related to security. Again, feature was implemented in the correct way. It's still insecure. And now it's questions time.
No questions.
Thank you.
It's more about your application. A few people can use your application for Tesla. For example, it's family where are 3 person.
Could you repeat?
I mean, 3 person use your application with Tesla for 1 car. So I can see what happens with this car at time when my friend uses it.
So it's basically one user per car, from
car.
what I know. Yeah.
One user. Okay.
Or at least it wasn't possible to create a separate account from the website or from application. Maybe it's possible from the service or something like that, but it wasn't possible in application to create additional user.
Okay, thank you.
Is there any security practice for mobile application used in general? Not only like technical one point of entrance or something like this, but did you dig deeper and analyze traffic to the server and so on? What certificates, pinning and so on?
Yeah, so I haven't checked this technical part because I saw something like that, and I think that the implementation is surely good enough. I mainly found problems with these assumptions. I checked checked the API because it's maybe not officially available, but it's well documented on the API service by the community. So I checked the API, tried to use both API and external libraries created by community. For example, if it's possible to honk the horn during driving and something like that, isolation of specific actions. And I haven't found anything, but I'm really not that security expert. I'm more like QA and I try to find problems in the whole product, not just this technical part. And I'm sure that security researchers I think security researchers already found everything that I definitely won't find there. So.
Что, поблагодарим спикера, и теперь будет закрытие.
Okay.
Закрытие, наверное, будет наверху.